When you take a standardized test, algebra test, you're going to definitely get some factoring and quadratics. And here is a simple example, x minus 4 squared. And I give you 5 choices. And the first two look very enticing. But let's work this out and see what we get. The first thing to remember is that this is actually x minus 4 times x minus 4. So let's first change this so we can see what we're going to be working with. Okay? And as soon as you do that, you're probably going to recognize that these two are not correct, simply because this is not x squared. First of all, it's not minus 16 because minus 4 times minus 4 is a positive number. And x minus 4, yes, x squared is x squared and minus 4 is squared, but when you have them together in the parentheses, you do not get x squared plus 16. So we cancel this one out. And we're down to our 3 possibilities. And as you're going to see, C is not going to work as well. But let's work this out. As you know, with the acronym FOIL, first, outer, inner, last. Let's figure this out. X times x is the first. We're going to get x squared. The outer will be x times negative 4, which is negative 4x. Then the inner, negative 4 times x is again negative 4x. And then the last is negative 4 times negative 4, which is positive 16. When we combine these middle terms, as you can see, this is not correct. When we combine these middle terms, we get negative 8x. So we finish up with x squared minus 8x plus 16, which is our final answer, which turns out to be D. Okay, how many factors of 120? This seems like a basic question. The trick is to make sure you have an organized count. Also, you want to recognize what a factor is. A factor is simply any integer, positive integer, that will go into a number. So for 120, it seems like it's a lot of counting, but realistically, if you organize and count in terms of pairs, you can minimize how many factors you'll have to keep track of. So let me just show you for this example. For 120, we know that 1 goes into it for sure, because 1 goes into everything. And to balance that out, we'd have 120 over here. Then we move on to the second number, which would be 2. 2 is a factor of 120 because 120 is even. And 2 goes into 120 60 times, so we'll put a 60 over on that side. Then we'll move along to 3. And 3 goes into 120 because 3 goes into 12. 4 and with a 0, so that would leave 40. And you can see how the numbers are narrowing. So now we only got to account for these numbers in between 3 and 40. So we move on to 4. And 4 goes into 120 30 times. So we have 4 and 30 as factors. And then continuing on, 5, if we do a little bit of division, 5 goes into 120 24 times. So we've got those, and our gap is closing. We will go into the 5. So we'll go into the next one, which is 6. And 6 goes into 120 20 times. And the gap is 7, does not go into 120. 8 does. It goes in 15 times. And 9 does not, but 10 does. So we're left with 12. And now we have our count. So let's see how many we came up with. We came up with 1, 2, 3, 4, 5, 6, 7, 8. And its counterparts should be 8 on this side. 1, 2, 3, 4, 5, 6, 7, 8. And that means there are a total of 16 factors. So the answer is E, 16. Now here's a basic square root problem, multiplication, to test if you understand properties of multiplying radicals. In this example, these both are square roots, so they are the same radicals. Therefore, you can multiply them. If this was the cube root and this was a square root, you would not be permitted to directly multiply them. But let's look at this example. An easy way to approach this is to recognize that these are all separate entities. This is 3 times rad 6. And of course, this is times 6 times rad 3. And if you view it this way, you can sort of start to pair things up. For example, we know 3 times 6 is 18. So we take care of these two. And then we also know that properties of radicals say if it's the same square root sign, we can multiply what's inside of it. So in this case, 6 times 3 gives us the square root of 18. So we now have basically narrowed this down to 18 rad 18. And of course, that's none of our answers from this appearance right here. So we need to simplify this and figure out which one of these is it. So if you remember reducing radicals, what you want to do is take this inside this radical and factor it or find out if there's a perfect square inside. And you can see there is. This is 2 times 9. And if we simplify this 9 and pull it out of the radical, we end up with a 3. So we have 3 times 18 times a radical 2. And 3 times 18 is 54, radical 2. And we find that is our answer below here, E, 54 radical 2. So what is the slope of 2x minus 3y equals 6? As you remember, slope is the relation between x and y. How much is the change of y in relation to the change of x? And a lot of you, hopefully not too many of you, will just look at the equation and say, look, whatever's in front of the x is simply the slope of the equation because you remember y equals mx plus b, and m is the slope. The only problem is this is in standard form, so the slope is not necessarily the coefficient of x. What we need to do is we need to actually move it into slope-intercept form. So let's do that. Let's take this equation, and the first thing we'll do is we'll subtract 2x from both sides. So we have negative 3y equals negative 2x plus 6. And of course you look at that and say, oh, wait, there is a negative 2 in front of the x. But again, we haven't put that in terms of y. So negative 2 will not be the answer because the y has a coefficient as well. So let's divide both sides by negative 3. And we get y equals negative 2x over negative 3 plus 6 over negative 3. Our intercept is negative 2, but we're not looking for that. We are actually looking for the slope, which of course is 2/3, which is C. And finally, a ratio probability question. Here we have a ratio of boys to girls is 3:2. And we want to find what's the probability of selecting a girl. So I have to recall that. So the first thing to remember is that a ratio and a probability, although they have a relationship, they are not the same thing. A ratio is simply saying for every 3 boys, you're going to have 2 girls. The probability of something is saying, look, what's the number of successes? Number of success, which in this case would be a girl, choosing a girl, over the number of possibilities, which would be total number of, in this case, kids, boys and girls. So let's take a simple example. What if we had 3 boys? If we had 3 boys, how many girls would we have? We would have 2 girls. If we had 9 boys, we would have 6 girls. But let's go back to the first example. We have 3 and 2. Okay, how many total do we have? Well, this is a 3:2 ratio, but we have 5 total. And how many girls would we can pick from? We could pick 2 girls out of that, which would give us a percentage of 2 out of 5, which is 40%. So again, the 3:2 is a ratio of how many to how many, but the probability what we're searching for is the chance that we pick a girl out of these 5. 2 out of 5 would be 40%. So our answer would be A.